Hey QED Coders, this is Michael, and I want to tell you all about the LaunchKings experience that we just had at the CodeLaunch World Championship just last week on Wednesday, the 12th. So we developed a new feature for LaunchKings and premiered it at the CodeLaunch event. And this new feature takes advantage of some capabilities of Jinaga that I think are really interesting and make a really good case study. And so today I want to go over that new feature, tell you about that experience, and kind of take you along on the journey. So come on, let's go. I'm going to start you off by going to, well, let's start off with a quick overview of the where is there it is. A quick overview of the system architecture for LaunchKings. All right, so right over here we have a Jinaga replicator. So this Jinaga replicator is the heart of the system. It keeps track of all of the facts, and so the client applications connect to the Jinaga replicator in order to exchange information. So that is a really important part of that system. So if we go over here, let's go and add a line. We've got the mobile application that the attendees are using. They are, of course, connecting to that Jinaga replicator in order to exchange facts to attendee application. So they are learning about who is participating in CodeLaunch, and they are voting for their favorite finalists within that application. And so all that information comes from the replicator and goes back to the replicator. Now over here we have a different application. This one is the admin application. So this is what an administrator would use in order to set up the event. So set up all of the finalists, and then they would also use this to run the event. And they're running that by going through this this Jinaga replicator right here. So we got that connecting to the Jinaga replicator like so. So they will push all of the event information into the Jinaga replicator. They will also update the state within the Jinaga replicator in order to open the voting. They will receive from the attendee application all of the votes, so they can display votes on the admin application. And so you can think of the Jinaga replicator as being the backend database for both of these applications that they're using to share information. But you'll notice something missing. Usually a backend database is behind an API. So there's another server in between the client application and the backend database, this server application. That's not in this diagram. That's because it doesn't exist in this architecture. It doesn't exist in a Jinaga architecture at all. The client applications connect directly to the replicator, and the replicator knows how to securely and efficiently exchange facts with those client applications. So you don't need to build an API to do that. That's what makes developing a Jinaga application so fast and fun. And so we've got these two using the Jinaga replicator. But how do we get here? Well, we got here by, first of all, these two applications used the, let's copy that over here, boom, the reverse proxy. Well, I'm really interested not in the reverse proxy features of Nginx. This is the Nginx logo. I am interested in the fact that they are accessing the code for the client applications. So this is the web server. So it serves up those client applications as static HTML and JavaScript files. And for the sake of what we're talking about here, that is all that we are really interested in. There are other aspects to what it does, but we can talk about those in just a little bit. So both these applications are going to the Nginx web server in order to get their get their JavaScript, get the HTML. Well, of course, it's not the application that's doing it, it's the browser that's doing it. So you navigate to LaunchKings.CodeLaunch.com, and it hits the web server, and it says /portal. Oh, okay, you want the admin portal. Serve it up to you. And then the application starts running, and it connects to the Jinaga replicator. Same thing with the attendee application. Now, here's the thing. The attendee application, the attendees are not typing in LaunchKings.CodeLaunch.com. They are scanning a QR code. So there's a little bit of interesting thing that's happening there. The admin application, when we set up an event, the admin also sets up some access paths. So an access path is a small set of instructions that tells the application how it's going to access the information in the replicator. So it's primarily concerned with authentication. So we have an attendee access path that represents general attendees, and this is the QR code that we show on the screen on the main stage. Everybody scans that QR code, and then they are let into the application. So the admin application creates it, the attendee application scans it, and this is the attendee access path. We will say this is the general attendee access path. Let's shrink that down because we want to talk about a new feature, and that means we're going to need to create a little bit more space. In addition now to the general attendee access path, we have a brand new access path, and this one is for investors. So here's our investor access path, and it follows the same workflow. The admin using the admin application creates an investor access path as part of the event, and so now there are two access paths associated with this event. The attendees who are sitting at certain tables at the front near the stage, they have invested some extra money that they want to allocate to the winner that they choose. And so the investors are scanning a QR code that is at their table. So we don't flash this one up on the main screen. There's a small pool of investors that are scanning that code. So now, how does this code scanning work? How does that get you into the application? Well, in order to do that, you need an identity provider. So this right here is the attendee identity provider. And its job is to create OAuth tokens in order for the application, the attendee application specifically, to authenticate with the Jinaga replicator. And so when you scan one of these codes, it is first going to load the attendee application, and then the attendee application notices, oh, okay, here's the attendee access path in the URL. So then it says, I need to go to the attendee identity provider in order to pick up my token. And so it makes a call over here, gets that token, and then uses that to access the Jinaga replicator. And so that's happening for both general attendees and investors alike. They are both grabbing tokens from that identity provider. The difference, however, is that this identity provider now interacts with the Jinaga replicator. It does that for two reasons. So we've got this connection now going to the Jinaga replicator. So the first reason is that whenever the admin application sets up an access path, it notifies the Jinaga replicator that it has created that access path. So whether you're using the general attendee access path or the investor access path, the attendee identity provider needs to contact the Jinaga replicator in order to get all of those access paths that have been set up. And then the replicator will replicate that information about that event that allows the attendee identity provider to validate, yes, that is a valid QR code. So I am going to issue a token. Now it also checks to see what kind of QR code it is. What is the attendee class? Are they a general attendee or are they an investor? Then once it checks that attendee class, it knows to do a few additional things. Now the usual way that you would do something like this is you would put a claim inside of the token, and then different parts of your application would check that claim as that token flows through. So add a claim to a token, that token comes up to the attendee application checks the claim in order to update the user interface, tell you, yes, you're an investor. But that's just the client application, and it's just user interface. That's not security. That's just showing a different UI. The security part comes in when the attendee application sends that token down to the Jinaga replicator. And if this were a third-party application, you would build in logic that would then check the claims in the token and authorize different activities. So check the claims on the token and then say, oh, these votes belong in that bucket, and move them over there. But that's not happening here. That's not happening because the Jinaga replicator is a generic piece of code. It doesn't know about LaunchKings. And so the Jinaga replicator, you can just download it from Docker. You can just spin it up inside of a container. And it's configured with different rules, security rules, distribution rules. And the Jinaga replicator doesn't have additional code to look for claims inside of the token and do special things. It's application agnostic. So how do we do that? How do we put special application behavior into a system like this? Well, that special application behavior lives in the identity provider in this case. So we've created an identity provider specifically for this application. It already knows about this application, and so it's the one that knows that if you've used this QR code and the investor access class, or the attendee access class is investor, then it's going to create a few additional facts inside of the Jinaga replicator. And so those facts tell these applications to behave differently. So the applications know to look for those facts. The attendee identity provider is authorized to create those facts, and it will only create those facts if it sees the investor QR code. Okay, so that's kind of the system architecture and how the things all fit together. Let's dive into some code. Let's take a look at how all of this works. I want to start with the admin application. Let's take a look at what the admin application is doing in order to set up these two QR codes. In fact, I am going to go ahead and log into, let's bring that over here. Let's go to launchkings.codelaunch.com/portal. And this logs me in to the LaunchKings admin portal. So this right here is our CodeLaunch World Championship 2025, where we have set up the finalists, and we've created these two attendee access codes. So we've got one that is for general attendees and one that is for investors. And so these two QR codes, they have these URLs. So they go to launchkings.codelaunch.com/attendee/access AAP, that's attendee access path, and then the GUID. Yeah, that's the name for it. All right, so how do we use that? Or how do we get that in the first place? Well, let's take a look at the model. So I'm going to go to CodeLaunch TS. Let's get everything all nice and neat so we can take a look at it. So we have within here several different facts that represent the attendee and all of the information about them. So here's the attendee fact. They are a Jinaga user within a tenant. They have information like the first name, last name, email, and then we're using the mutable property pattern in order to replace and update that information. Here's their language preference, English or Spanish currently supported. There's the link between the attendee and the event. It says this particular attendee is attending this event. And here is the attendee event class. So that tells us that an attendee at this particular event is has registered with this particular access class. So if we have an attendee event class and this attendee class is investor, then we treat them like an investor. Okay, but how do we get there in the first place? Well, all that comes from this bookkeeping model. So here we have the attendee access path. Actually, it's back here in CodeLaunch, the attendee access path. So for a particular event, we create a brand new ID for the attendee access path. That's the GUID. And then we can optionally declare an attendee class. So I made this optional for a couple of reasons. First of all, this was an existing fact. I already had a fact that didn't have attendee class as a property. So by making it optional, or undefined, this allows me to evolve the model. The old attendee access paths would have undefined here. And so they would look like general attendee access paths, which is what I intend. Or you provide a specific string, and now the string investor means that they're an investor. This also allows room for growth, where we can have additional attendee classes. Okay, so this was created at a particular date. When it's serialized, of course, that date becomes a string, so we allowed both of those. And so that's our attendee access path. That represents the QR code. That represents this right here. And so now we need to know, is this a general or an investor attendee access path. And in order to find that out, we use another fact. So let's look at the references of this and see if we can find that other fact. Here inside of bookkeeping, we have attendee access path configured. That's not the one. Or, where did it go? Yeah, so we have a, oh, actually, sorry. How do we know that property? I just talked about it. Okay. So now we've created these two QR codes. Let's go back to the diagram. From the admin application, we've created these QR codes. At the time that you create a QR code, add an access code, you get to choose general access or investor access. And it sets that property. So, nice and simple. And then, now the attendee scans the QR code. So as we saw, that QR code goes to the attendee application. Well, let's go there and see what it does. So we're going to go to app.tsx in the attendee application. And we see all the different routes. Here's the access AAP with the AAP ID. It goes to the access component. Okay, so this is primarily here to navigate us to the identity provider. So we can see, all right, we're going to look for that AAP ID in that URL. We are going to then initiate auth by calling this login function that comes from use access. So here's our access provider. So this is a context. How is this set up? Here is the login function. Somewhere up here is the login function. Let's take a look. So here's access provider. Yeah, so we've got our APID. Where is login? Go to or find login. Here's our login function. All right, come back here. What are we doing? We're calling use access. We are, yeah, here's the login function. Access provider. So set the AAP in the context and then do the auth login. So this is calling, if I scroll up here, auth login. Where did it go? Come on, auth login. All right. From the auth context. Okay, auth context. If I am not mistaken, yes. This comes from a module called React OAuth 2 Code Pixie. So this is initiating the authentication. And it does so by creating an authentication request and redirecting to the authentication provider. So this has been configured to redirect to this identity provider. Now, in addition to doing the regular OAuth 2 redirect, it is also passing this AAP ID as a parameter on that query string. So you're allowed to add additional parameters to the query string. And so the attendee identity provider knows which QR code you've scanned. It's got the AAP ID. That's how the browser bounced from here to here. Now, let's take a look at the attendee identity provider. So let's go to, I want to go to router, let's see. I thought it was called router, but let's go to the attendee identity provider. And inside of the routes method, yeah, here we've got auth, and we are going to come in here, and we are going to receive the AAP ID. So we've got our AAP ID that is coming in, and now we are going to use that AAP ID. How are we going to do that? So that inside of app attendee IP star.ts. How does all of this come together? Well, we are going to there we are, create a that's setting up the access path itself. Let's jump straight to creating the attendee access path. Not the attendee access path, sorry. The attendee event class, because that's ultimately what we were trying to do. So the attendee event class, we are going to create one of these. This is all my tests. This is where we set it up. Okay, so we've gone through the OAuth workflow, and now we have an attendee access path. How did we get this? Get the attendee access path by AAP ID. So use that GUID to get the attendee access path. That talks to a repository, so it's got this little SQL-like repository that it keeps in sync by calling the Jinaga replicator and storing it into the repository. So it gets that AAP ID. We've got our AAP right here. And from that AAP, now we know which event we're talking about. We've got our event here. And then we also know down here which attendee class. So knowing that event ID, we're going to create the fact graph leading all the way up to that particular attendee. So what's the tenant? Well, we are inside of a tenant that was created by a user that was a single use, one-time user. And so we know its public key. That's been configured in the entire application. Everybody knows the tenant for CodeLaunch. And then what's the event? Well, the event is this particular event ID within that tenant. And now we know which event we're talking about. Notice these are just creating new objects. These are just new classes. That's all it's doing right there, just creating these JavaScript classes. And then we create a new attendee, which is the user's fact within the tenant. How do we get that user's fact? Well, we use another Jinaga client, which we log in using their access token that we just generated. And when we log in to the replicator using that access token, now we are we're basically emulating that user, and we've got that user fact. So we use that in order to create the attendee. And now we've got the attendee event, which is that attendee at that event. So we've just created this graph. You can kind of see, the tenant up here, the event down below that, the attendee user up here, and the attendee event below those two. And then we do a Jinaga client.fact and create the attendee event, which, if necessary, creates everything above it. So that means that the attendee fact probably didn't exist before this. So this is going to create the attendee event and the attendee. It's going to create those two facts. These others probably already existed. So it's not going to end up creating those. So that fills out that graph. And by calling await, that means that we are sure that we have created that within the Jinaga client. So if the Jinaga client is configured to not have a local store, but instead just use the replicator, then that means it's going to await the response from the replicator, and it's made it all the way there. If it has local storage, then it'll just save it locally, it'll queue it up, and then it'll resolve. But this one is set up not to have local storage for the replicated facts, so this is making sure that it's in the replicator. And then we check to see if it's got the attendee class. And if it does, we create an additional fact for the attendee class. So this attendee event, so at this event, this attendee is an investor. And so that gets all of that set up inside of the replicator. And so now after scanning the QR code, the graph is constructed, including the attendee's class. So this attendee event class. So now the attendee application can respond differently based on that attendee event class. It can, in this case, change the color. So we go from a multicolored user interface to a gold-plated user interface. So the investors see a visual indication. Oh, I am an investor. And then the more significant part is the admin application is able to respond differently to those two different kinds of attendees. Let's take a look real quick at what that application can do. So in addition to the setup here, we've got our event dashboard. And so here we can see that when the lightning round is open, that we are collecting votes from two different pools. So we've got our general attendee votes and our investor votes. So this application is receiving all that information and aggregating it. What you can see here is that it is pulling from those feeds and updating the user interface as it does so. In fact, we might even be able to catch it in the act if we take a look at the network tab. Let's go ahead and do a refresh. And we can see that it is pulling from these feeds. You can see pending right here. It's waiting for more facts. So I think it's already caught up. But that was pulling all of that vote information down to the admin application. And that allows us to see the general attendee votes and the investor votes, and then declare the winners. So they're able to announce these winners on stage that people have voted for in real time. It adds a whole new layer of interactivity to the event. It's pretty awesome. So how is the admin application aggregating these votes into these two buckets? Well, let me show you. So the admin application is pulling all the votes from the Jinaga replicator. And so let's go to the admin application. Here it is. And we are looking at the event dashboard. So let's close the others, focus just on this one. We've got use event votes. So that is the custom hook that does all of this. So we are going to subscribe right here to the voting round allocations. That's specified right up here. Here are the voting round allocations. So given a voting round, which is a fact within an event, you can see right here, a voting round is within an event and it has a round number. So this is going to be, I believe I used 1 based, round 1, round 2. Can't remember for sure. But so in that voting round, we are going to look for the vote allocations inside of that an attendee event for an attendee. So we're going to, okay, rewind. All right, given that voting round, first we're going to look for the vote allocations in that round. So this is a little helper function that says we're going to find the successor vote allocations, so a vote within a voting round. So that is looking at this vote allocation. So give me all the vote allocations in that particular voting round. Now, once I've got those, I've got the attendee events, so I know which attendee made that votes and what event they're in, and I know what their vote allocation was. So that's just going to be a string representation of all of their votes. Now that I've got those voting rounds, I'm going to do a select many in order to get the user. So the vote allocation, attendee event, attendee user. So it's called select many, although when you go up this path, you're going to 1 attendee event, 1 attendee, 1 user. Yeah, there's nothing in Jinaga that says that a predecessor has to be singular. You write the code as if it were, but once it gets to the replicator, it's many and many. So it's always select many. And so you have to kind of remember that as you write these specifications. So now I've got all of the users that have voted in that round. And so I also, because I'm still inside of this, this select many, I also have the vote allocation. So this gives me access to the vote allocation fact and the user fact. I'm going to use the user fact in order to create the attendee, or to get the attendee's public key. That way I know that's a distinct user. And then the vote allocation, I'm going to get the ID of that vote allocation. I'll get that string, the time it was created, and the attendee class. Well, this is attendee classes. Okay, so this is the new part. It was doing all of this before, but now it's also getting the attendee classes of that particular attendee event. So given the vote allocation, this is a vote allocation within an attendee event. What is the attendee class for that event? So give me all the attendee event classes for that. And here I'm just looking for the successors attendee event class that reference that same attendee event. Okay, so vote allocation, go up to the attendee event, and then go back down to all of the attendee event classes. There should only be 1 or 0. For the general attendee, there will be nothing. For the investor, there will be 1, but there's nothing about the Jinaga model that prevents multiples. So we call it attendee classes, and the type that we get back is actually a traversal string, which turns into an array of strings. So now we've got the attendee classes. So this is the structure that we've got, a whole array of these votes. So what am I doing with all of this information? Well, here I'm setting up a subscription, and this subscription has a callback. So when I receive a brand new allocation, I'm going to go through this callback. I'll set that into this state. So set voting round allocations. This is a React state variable. And then I will also call on added for the attendee classes collection. So that turns into an observable collection, so that when an attendee class is added, I will set the voting round allocation to change the item in order to add the attendee class. So now I've got that array of attendee classes. So this is just the React way of every time a new projection comes in, I'm going to update some state. And that state gives me this voting round allocations. So let's take a look at how we are using the voting round allocations. Right here we can see that's associated with this state variable here. And so we are doing a loop over those things, and we are finding the allocations by attendee, so grouping those by attendee, getting the most recent one, and so for the most recent one we are setting the allocations and its current date and the attendee classes for that allocation. So now allocations by attendee is basically those votes grouped by attendee's public key and the most recent one. Then from there we're going to parse out the allocations, and now we're going to pivot. So we've got our parsed applications, we've got now our investor class allocations and our general class allocations. So here we are separating those into two different buckets. Investors go over here, and anybody that does not have an attendee class of investor, they go into the general bucket. And so now these are all of the votes. So we just parse the votes. We throw away all the other information because now we've already got just one row per attendee, and we just have their most recent one. So we've pivoted. Now we just have the investor class allocations and the general class allocations. So it's at this point now we've got all those different allocations. We do a reduce where we sum up all of those allocations, and now we've got just one array of total general allocations and investor allocations. So these are number arrays. These are these two number arrays. That's it. So we have reduced it down to just 3 values here, 3 values there inside of those arrays. And then we're able to display that on the user interface and show how things are updated. So you can see that by taking advantage of the strengths of Jinaga, I'm able to share information from the attendee application, subscribe to it in the admin application, and do that processing. You can see how, because the Jinaga replicator is application agnostic, I've moved all of the application code into the identity provider and into these applications. Now, what you might also be concerned about, and I am as well, is the fact that while we were waiting for this screen to settle down, it was loading all these individual facts. And it's doing that because every time it receives a new fact, it comes back through this code to aggregate all of that information. And all of this is happening on the client side inside of the admin application. That's a concern. Don't you agree? The problem is that every time you open up the admin application on a different machine, then you're going to see this play out again. You can't just simply get the most recent state. So we really want this information to aggregate somewhere on the server, and we want that that aggregation to be stored. And so where should it be? Well, this is just Nginx. That's just serving up static files. This is an application-agnostic replicator. It can't house code to do this aggregation. And this identity provider, well, its job is to set up the attendee's identity in their initial graph, but yeah, it's running application code, but it's not for that purpose. that means we need something else. That something else could be a new application. So, let's say that we've got this new application over here that is talking to the Jinaga replicator. Okay, so it's got a job to do, and it talks to that replicator in order to do it, and then it exposes another endpoint for this to use. So that could be doing that aggregation, storing that in its own local store, and then the admin application can retrieve it. That's one idea. So I will label that as a custom aggregator. But let me tell you about another idea. What if we had an application-agnostic aggregator? Actually, you might already be familiar with an application-agnostic aggregator, something called Kafka Streams. So when you deploy Kafka, you're deploying a store for information. It's something that's very similar to a Jinaga replicator in that it stores the information. It doesn't know what your application is, but it's got all of the events that occur in a topic, all the messages. But Kafka Streams is a library that you can use within typically a Java application in order to set up some stream aggregation functions, and then it reads from those topics, performs those functions, and writes the results back to Kafka topics. So you could create a custom Kafka Streams application. So write that in Java and deploy that. In order to do that, you would also need to set up some Kafka nodes, and you would also have to set up Zookeeper, or if you're using a newer version of Kafka, you don't need the Zookeeper, but there's additional infrastructure that goes along with that. So what if there were an application-agnostic component that could perform aggregation and then also be that infrastructure? So rather than writing the results back to Kafka Streams, it stores those results. And so this I call the Jinaga aggregator. So this is the next component that I want to build within the Jinaga ecosystem. So the Jinaga aggregator will subscribe to specifications within the Jinaga replicator. In fact, it would be this specification right up here. So you'd provide that specification and say, all right, Jinaga aggregator, subscribe to that. And then the Jinaga aggregator would have a language that you could use to express these functions. Where are they? Yeah. Oh, that's the suspicion stuff. That's a cool feature. We'll talk about suspicion in a later episode. Yeah, those are the locations. Let's come back here. Yeah, here we are. Yeah, so all of this, here we're using loops in order to look for the most recent, in order to group them by attendee public key, all that stuff. So all of the stuff that we're doing in code, we could do in a language similar to the specification language that then the Jinaga aggregator could run. So it knows to do a select. So it takes a stream of it's going to start with the projections from the specification. So a stream of those projections, and then it using that select, you might change the shape of it, select different things from it. Then it would have grouping, so group by the attendee public key. And so now you would get out a smaller set that would be the attendee public keys, but then within that set you would have a subset which is all of the allocations for that attendee. And then you would have a maximum operator, so select the one allocation that has the maximum created at date. So now it takes the latest one, and now it gives you that one. So these operators operate on these streams, similar to using Kafka streams, and all of that can be expressed in a language that is uploaded to the Jinaga aggregator, similar to the code that is uploaded to the Jinaga replicator. Let me show that code just so we can see what's happening here. So within the not Nginx, but within the replicator, we've got things like our authorization rules and our distribution rules. So all of this code is generated by our applications and then interpreted by the replicator in order to enforce those rules. So let's suppose that we did something similar here, generate some specifications and some aggregation instructions, have the Jinaga aggregator run those, and then provide an API and a client similar to the Jinaga client that you could use to subscribe to those aggregates. And then the aggregation would happen in real time there. It would be stored there. It wouldn't be recomputed all the time, and it would be done in the most efficient way for that particular pipeline of aggregation functions. And then the admin application would just call the Jinaga aggregator to get the final result. It would make one call, it would get this back. Or it would create an open connection, a WebSocket, server-sent events, whatever, in order to get the most recent. So it gets notified whenever this changes. So you would still get the real-time updates while people are voting. They would vote, go to the replicator, the subscription would fire, say, oh, here's new information, run it through the pipeline, update all of the I want to be careful about using the word projections. Yeah, update all of the the stages in the pipeline, and then give you back just the final result. So have that pipe through. That's the next component that I want to build. So that's going to be awesome, and that component is really going to help out with the performance of this admin application. It's also going to help out with the suspicion calculation that I just hinted at, so that we'll be able to, without doing all of that work on the admin application, detect who is voting from outside of the venue. So that's going to be very useful as well. So that's the brand new application, the brand new feature, the investor access path, and a coming component within Jinaga, the Jinaga aggregator. The next CodeLaunch event is in April, and that is going to be, I believe, that's going to be the LATAM. So yeah, we are going to be going back to Guadalajara. It might actually be the Canada event, so going back to Toronto for that. Either way, we're going to have the Jinaga replicator, the Jinaga aggregator in place to support that, and as we add it here, also going to make it available to you, so you can play with the Jinaga aggregator and build a full end-to-end distributed system that uses replication through all of these components. So join me on that journey. we will walk through building that aggregator together. And yeah, I am looking forward to talking to you next week. Build something awesome.